Alright guys, day 5, last day of the week. I know it's been a lot, but we're getting there. Alright, so today what we're going to do is we are going to start talking about fractions. And I know everybody loves fractions, not really, but we're going to hopefully bring back some of that knowledge that you have of fractions. And we're going to start out by talking about what it means to be equivalent fractions. Alright, so let's say that I'm going to look at these three fractions. 2/3, 4/6, and 6/9. All three of these fractions are what we call equivalent because they have the same value. So another word or another way to say equivalent is to mean that they have the same value. 2/3 has the same value as 4/6. 4/6 has the same value as 6/9. Okay. This is going to come in handy as we get into the next week. We're going to look at adding and subtracting fractions, multiplying, dividing fractions. So equivalent is going to help you when we get into some of that stuff. One of the things that we're going to talk about today is what it means to reduce. On ACT, on K-Prep, a lot of your different types of tests, what happens is you will get an answer, but that answer will not be there. And the reason being is they have reduced it or they've changed it. And so therefore you have to be able to look at that and figure out which answer is the same as yours, which one is equivalent, which one has the same value. So we're going to talk about how to reduce a fraction to lowest terms. A fraction can be reduced to an equivalent fraction in lowest terms by dividing its numerator and its denominator by the greatest common factor of the numerator and denominator. Just to go back and review really quickly, the top number is the numerator, bottom number is the denominator. In other words, I can reduce my fraction to lowest terms by dividing both of those numbers by the same number. And I want to do it by the greatest number that I possibly can. So let's look at a couple of examples. Let's look at 8/36. I want to reduce this fraction to lowest terms. Now, I've got to think about this. You can do this a couple of different ways. I'm going to write it out the longer way so that you can actually see what I'm doing. But I want to look for the GCF, the greatest common factor. We just did that not too long ago, so hopefully it's still fresh in your mind. Alright, so I'm going to list all the factors of 8 and all the factors of 36. 1, 2, 4, and 8. 1, 2, 3, 4, 6, 9, 12, 18, 36. Now, if you remember, greatest common factor is the biggest number that they have in common. So I can look at my numbers and see that they have 1, they have 2, they have 4. So I'm looking for the greatest number. 4 is the greatest number they have in common. So in order to reduce this fraction into lowest terms, I have to divide both the numerator and the denominator by 4. Let me take a step back for just a second and tell you, I can divide both of these by 2, but you're going to see it's not the lowest that it can go. The whole point of reducing your fraction is to get it the lowest that I possibly can. So 8 divided by 4 is 2. 36 divided by 4 is 9. So 8/36 would be written in lowest terms as 2/9. 2/9 and 8/36 they are equivalent fractions. They have the same value. Let's look at another one. Let's look at 36 over 84. Now, this one can get a little trickier because my numbers are getting a little bigger. 36, we've already listed the factors of 36. Now I have to look at the factors of 84. Once again, you can list those factors if you would like. So I've got 36 with 1, 2, 3, 4, 6, 9, 12, 18, and 36. 84 would be 1, 2, 3 would go into it, 4 would go into it, 5 will not, 6, would go into it, 7 would go into it, 8 will not go into it, 9 will not go into it, 10 will not go into it. So I think now we're at the point, this would be 7 times 12, 6 times 14, 4 times 21, 3 times, let's see, that'd be 28, 2 times 42, and then 84. I'm trying to do this in my head, guys, so you have to forgive me. Alright, so now I can look and see what they have in common. So it looks like the highest number that they have in common is 12. So I need to divide both the numerator and the denominator by 12. 36 divided by 12 is 3. And 84 divided by 12 is 7. So 36 over 84 in lowest terms would be 3/7. Those are the steps in reducing a fraction to lowest terms. Let's look at just a little bit different of a fraction. All right, we're going to look at something using exponents. All right, so let's look at 3 to the 4th times 5 cubed times 7 over 2 cubed times 3 times 5 to the 5th times 7 squared. Okay, let's talk about how we would do this. The simplest way that I can tell you to do this is, there's other ways, there's several different ways you can do this, but the simplest way I can tell you to do this is to look at your bases. Remember, the 3, the 5, the 7, that's your base. The 2's a base, 3, 5, 7's a base. Alright, so by doing this, what I can do is I've got to factor out that GCF. Alright, and if you remember, let me see if I can find my notes here. When we looked at GCF, finding the greatest common factor of GCF, when I dealt with prime factorization, what I did is I had to figure out what they had in common and then I pulled out what they had in common. So for example, when I went back to 36 and 40, 2 squared and 2 cubed, they both have the same base of 2. And then remember, I wrote these down here, and I figured out how many they had in common, and that's what I pulled out. So I'm going to treat that very similar. I'm going to treat this problem very similar. I've got to look at what I have. All right, so I've got 3 in common, I've got 5 in common, I've got 7 in common. All right, so I'm going to look at my 3, and I'm going to see what they have in common. All right, I'm going to factor out that GCF from the numerator and the denominator. So let's look at our GCF. Our GCF I've got 3 to the 4th and 3. So I'm looking at 3. I've got 5 cubed and 5 to the 5th. So I'm looking at 5 cubed. And then 7 and 7 squared, I'm looking at 7. Okay, so there's my GCF. So now I've got to factor that GCF out. Okay? That means I've got to take that GCF out. So if I take out of the numerator a cubed, what am I left with? I'm left with 3 more of them, right? If I take 5 cubed out of the numerator, do I have anything left? No. If I take 7 out of the numerator, do I have anything left? No. So the only thing that's left on the top is 3 cubed. Let's look at the bottom and do the same thing. I'm not factoring anything out with the base of 2. Okay, because that's not part of my GCF, so that stays. All right? I want to factor out a 3. Well, there's only 1 3 down here, so what happens? There's nothing left. I want to factor out 5 cubed. That leaves how many 5s left? That leaves 2 of them. I factor out a 7. So how many is left? That leaves me 1. So this is the equivalent of my original problem because I have factored out that GCF. Okay? I know it's a little confusing, but you'll get the hang of it, I promise. All right, let's do one more problem like this. We're going to make this one just a little bit more challenging. All right, so we're going to look at 24 x squared y to the 4th z to the 7th over 18 x to the 5th y to the 2nd z. Okay. Remember, all I'm trying to do is reduce this. I want it to be the smallest that I possibly can get. All right. So let's think about the GCF. Let's think about that for just a second. The greatest common factor. What is the biggest number that I can pull out of 24 and 18? Well, let's think about this. 24 is 1, 2, 3, 4, 6, 8, 12, and 24. And 18 would be 1, 2, 3, 6, 9, and 18. So 6 is the biggest number that I can pull out. So I'm going to pull that 6 out. Let's look at my x squared and my x to the 5th. How many of those can I pull out of there? Well, they only share 2 x's. I can't pull 5 out because it's not fair. There's not 5 up here. So I can pull out 2 x's. Let's look at our y's. I've got 4 up here and 2 up here. So I can pull 2 of those out. And let's look at our z's. I've got 7 up here and 1 down here. I can pull 1 out. So my greatest common factor is this, 6x squared y squared z. All right, with that being said, now I'm going to factor out all of my greatest common factors. In other words, I'm going to divide it. So, if I divide 24 by 6, what do I end up with? I end up with 4. X squared divided by x squared, there's nothing left. Y squared, if I take 2 y's out of there, what do I have? I end up with y squared. And if I take a z out of here, I end up with z to the 6th. Let's do the same thing down here. 6 goes into 18. So 18 divided by 6 is 3. I have x to the 5th. I'm going to take 2 of those away. So I'm left with 3 of them. Y squared, I'm taking y squared away from it. There's nothing left. I'm taking z away from z. There's nothing left. So this is my fraction in lowest terms. I cannot go any further down. One of the things that I want you to pay attention to, notice that I don't have an x up here. Notice I don't have any y's or any z's down here. I only have that variable. I only have x in one spot. I only have y in one spot. I only have z in one spot. All right, it's not in both the denominator and the numerator. If that were so, then I would not be in lowest terms. All right, so the last part of this lesson today is what we call mixed numbers and improper fractions. So there's a debate as to whether they're actually called improper fractions anymore, because when we think about the word improper, we think of it being wrong. It is not wrong, it's just not written the way that we normally think about a fraction being written. Okay? So we have to be really careful about how we use the word improper. But an improper fraction means that you have a fraction whose numerator is greater than the denominator. So maybe it looks something like this. Maybe it looks something like this. The numerator in this case is greater than the denominator. And this is what we call an improper fraction because we don't normally see it written like this. It doesn't mean it's wrong, it's just not normal. So what we can do is we can actually rewrite this as what we call a mixed number. Okay? A mixed number means that I'm going to have a whole number and I possibly could have a fraction left over. So let's talk about the steps of changing an improper fraction to a mixed number. The first thing you're going to do is you are going to divide the numerator by the denominator. Okay? So I'm going to divide this. 5 goes into 12 how many times? Well, it may not go evenly. It might, but it may not go evenly. So I've got to get it to the closest that I can. 5 goes into 12 2 whole times. That's 10. 5 times 2 is 10. All right? The next thing I'm going to do is I need to subtract the product of my whole number and my denominator from the numerator. So I'm going to multiply the denominator by the whole number. So 5 times 2 is 10. Okay? So 12 divided by 5, and let me write this out here, is 2. Then I'm going to say 2 times 5 is 10. Now I'm going to subtract the product from the numerator. So my product was 10. I'm going to subtract that from the numerator, which is 12, and that gives me 2. That now becomes the numerator in my new fraction. And then my denominator never changes. So I have now taken 12/5 and I have rewritten it as a mixed number because it has a whole number and a fraction left over. Okay? So I have to do a little bit of division, I have to do a little multiplication, I have to do a little subtraction. There's several steps here. All right, let's look at another example. So I'm going to, step number 1, divide. 6 goes into 47, or 47 divided by 6 is what? Well, let's think about this. 6 times 7 is 42. 6 times 8 is 48. I can't go bigger, so I'm going to go, okay, it is 7. 6 times 7 is 42. So 47 minus 42 is 5. And then my denominator never changes. If I divide it by 6, my denominator is going to stay 6. Now on the flip side, I can take mixed numbers and I can rewrite them as improper fractions. You will sometimes see that too. Sometimes you will see, take this and rewrite it as an improper fraction. All right, so let's talk about how we would do that. So let's say that I have a mixed number of 2 3/8. You're going to do a couple of things. You are going to multiply the denominator and the whole number. Okay, so I'm going to multiply 8 times 2. Then I'm going to add the numerator to your answer. All right, so if you want to put those signs in there on your problem, you can do so. So I'm going to say 8 times 2 is 16. 16 plus 3 is 19. And then once again, my denominator does not change. It stays 8. So if I want to rewrite 2 3/8 as an improper fraction, I would rewrite it as 19/8. Guys, I hope you've had a great first week. I know it's not what we were hoping. It's not typical, but hopefully you will reach out to me. The one thing I want you to understand is most of you are in English transitions and math transitions at the same time. It's the same class period. So what's going to happen is Miss Christy and I are going to work together. You're going to do math the first week. Next week, you will be getting English assignments from her. If you are only in the math transitions class, then I will make sure that you have an assignment for you to work on the week that they are doing English. And we're going to flip back and forth each week. Guys, if you have any questions, please feel free to contact me. Hope you have a great weekend.